Alright, so now let's walk through what happens behind the scenes when you interact with metadata in Snowflake. Imagine you're running a simple query like a select star from users. You might think Snowflake just scans the table, but there's so much more that happens behind the scenes, especially when it comes to metadata. Here's a step-by-step process. Number one, query parsing. When Snowflake receives this query, the parser identifies the table users. To know what this table contains, Snowflake checks the metadata. It looks up the key, something like schema, users, columns, to find the column names, the data types, and structure. Number two, query optimization. The optimizer needs to figure out the most efficient way to run this query. It will check for the metadata about macropartitions to see which part of the table are relevant. Using zone maps, which store the min-max value columns for each partition, Snowflake prunes away the irrelevant data, ensuring that only useful partitions are scanned. Query execution. Once the query optimizer decides on the query plan, Snowflake requests the metadata on where the relevant partitions are stored in Cloud Object Storage, like S3. The key takeaway here is that every stage of query depends on metadata, from planning to optimization to execution. All of this metadata is accessed using FoundationDB. Because metadata is stored as a key value pairs, it can be retrieved and updated extremely fast even if thousands of users are running queries at the same time. Next, let's move to one of the most important concepts in Snowflake's metadata system, the global transaction model.